It's due to something known as the Coriolis force. In a simple, flat world, cold wind from the poles would travel towards the equator, while warm wind from the equator would float over it towards the poles. But the world isn't a simple flat sheet. It's a rotating sphere. You are traveling right now at somewhere between 0 km per hour, if you're at a pole and decided to listen to an Astron podcast while you were there, and 1,600 km per hour at the equator, from the west to the east. You might not notice this fact because everything next to you is, on average, traveling at the same speed in the same direction. But what happens if you were to travel from the equator to the pole? Conservation of momentum states that you would still be traveling eastward at the same speed as previously, but suddenly the Earth beneath you is not traveling quite so fast. Remember, at the pole you'd have 0 eastward speed, but would simply be rotated slowly. If, on the other hand, you keep all your eastward momentum from the equator and travel towards the pole, suddenly it will appear, compared to everything else, like you are traveling east really fast. In practice, this means that air that travels up towards a pole from the equator, whether towards the North Pole or the South, will not go straight up, but over large distances will start to curve towards the east.